Hello, Tom from Every Step Calculus, everystepphysics.com. I do these programs for one reason: for you to pass a test, and if you're lucky, do some homework, get some homework done. Mainly tests. Get tests from all over, and I program from test problems. Test problems have to be relatively simple, even though nothing's simple in calculus, because it's 10 million puzzles like Sudoku or crossword puzzles. That's all it is. It never solved anything at NASA, never solved anything in life worth anything, in my opinion, after 25 years of studying this stuff. Any more than multiplying two numbers together can give you the answers for curing cancer or whatever, you know. Look at this problem here. We're dealing with sine waves. Okay, here's sine waves. Nonsensical adding things together in the functions, three-dimensionals, x, y, and z. And then all of a sudden somebody decides that they're going to have a time times the, to the fourth power, or minus time to the fifth power, t, None of this nonsense would ever happen in real life. These are just puzzles to see if you can calculate them, okay? Well, I can calculate them in a program. Why would I ever try to learn this stuff and memorize it and put it to my fabulous memory if it's worthless? And I know it's worthless, so I'm not going to memorize it. I'm not going to study it, okay? That's the reason I created these programs, and you can take advantage of them too. You can go to my site, buy my programs for $40 and pass calculus. It's simple as that. Don't have to study this crap, okay? So anyways, index 8 to get to my menu. Let's do this problem. This is the problem I got off of Yahoo, one of many. Now, one thing I do want to teach you about line integrals. I'm going to press number 7 here because this is what we're after here. No, we're not after that at all. We're going down here to line integrals. Sorry, I was ahead of myself here. I got so upset over calculus. Now, I'm an expert at line integrals now because I've studied it and programmed this stuff for, well, relatively years, but really pushed it hard the last month here. So I know line integrals, and we're going to go here to line integrals here, press enter, and this problem is I, J, and K. Okay, so we're going to choose that number 7 in the menu, I, J, and K. Now, these are all of the possibilities of line integrals that I have found when they give you a problem. They're going to give you dx, dy, you'll choose that. dx, dy, dz, the function with x and y, no z, function with x, y, and z, or the function with I and j, and k. These are all tricks by professors to screw you up and see if you know everything that they teach. They put a simple problem of line integral on the blackboard, and then all of a sudden teach this god-awful stuff with sines and cosines and etc. how they do this. So anyways, we're going to go to number 7, press number 7 to get to that in the program, and we're going to enter the variables. Now, this turns in calculus 3 to m, n, and o. Okay, m, n, and o. So here's the m one. Now if we're going to enter this sign of here, we're going to press alpha, and we're going to press sine. We're going to go to sine, which is second, and y. There's sine. We're going to put the x in there, close off the parentheses, and press enter. Okay. Now the n function is same thing. You go to here and press alpha and put in the sign, etc., etc. In my program, you have to press alpha first. Remember that. I've already loaded this stuff into the simulator here to make it easy. And here's what they've entered, right? X times z. Here's x times z here for the k, and dr. Okay. The dr shows you that there's an RT function, and you're going to do the derivative of the RT function, which equals the dr here. Okay, so I say it's okay when you enter these variables And was segments given? No. Segment is when they give you points. A segment going here, like in a triangle, segment going up, and a segment going here, etc. 2 segments, 3 segments, whatever. So there's no segments given here, so we say no. Okay. Now is I, J, and K given? Yes. Yes for C. Okay. And so we're going to press yes on that, and we're going to enter the term before the t term before the I. Here's the I, and here's the t term before it, t to the 4th power. Now, again, you didn't press alpha and put t to the 4th in there, and I'll do it for you here. Alpha t to the 4th. There it is right there, okay? And we press enter. Now we've got that entered. Now we're doing it for the other 3, but I've already entered them in here now. Okay, so we have t to the 4 minus t to the 5, and then t for k. Notice this nonsense, you know, times the power of the 4th, you know, times minus time to the 5th power. You know, how would that ever relate to anything worth anything in this lifetime, okay? So I say okay if it's all good. We're going to enter the range. Range when in our t functions is always 0 and 1. So I've already entered that too, 0 and 1. But if they gave you something different, I suppose they could if it's a puzzle, and you could enter that yourself, okay? I say it's okay. Now we have x equals t to the 4th here. The derivative of that dx is 4 times t cubed, okay, dt, etc., etc. You mark this on your paper. It systematically does these computations for you. Here's the original integral. It's changed with dx, dy, and dz here instead of I, j, and k, because you have to multiply the problem with dx and dy and dz, which we just found in the previous screen. We're going to substitute all these in for the x and y. Here we do it here. Now you're going to put parentheses around these quotation marks because I've entered them in for x, and here's the dx, right? Here's the y, and here's the dy, etc. And it's over the range of 0 and 1. Here's the integral, okay? We're going to condense it, clean it up. Here's the real integral after we multiply things together. We're going to integrate. Try integrating this stuff in a test, huh? Easy, right? I don't think so. Over the range of 0 and 1. Now at t equals 1, you have cosine. We're entering the 1 for all the t's in here in what we just found. And here's the answer, minus cosine 1 minus sine 1 plus 1 over 6. Okay? At t equals 0, turns out to be minus 1. Now upper minus lower, that's always the case in physics and calculus. When you do anything over a range, it's always upper minus lower, okay? And here's the answer. And here's minus minus 1. You'd probably put down plus 1 here, which would be correct. And plus 1, you know, is, of course, 6, 6, and then you'd have 7, 6 here. But here's the answer, minus 0.215, okay? Go to my site, buy my programs, and enjoy passing calculus. Have a good one.